Good morning, ma'am and sir. Title of our project is Text Similarity Identification for Marathi language text document. Nowadays, the amount of plagiarized content is increasing day by day on World Wide Web. Hence, the need of text similarity identification system comes into picture. The text similarity is one of the essential techniques of NLP, which is being used to find the closeness between two chunks of text by its meaning or by surface. Words can be similar in two ways, lexically and semantically. Words are similar lexically if they have a similar character sequence. Words are similar semantically if they have same thing, are opposite of each other, used in same way, used in same context, and one is type of another. Now we have used the lexical approach in our project to find the closeness between the two documents. Now let's look at how lexical similarity is obtained step by step. First, in step 1, we open the first document and then with the use of stanzas, word and sentence tokenization is done to get a list of words and count of words per sentence to average it in further steps. Let's see an example. Here we are giving the input as मंगल ग्रह एक ठंडा रेगिस्तान दुनिया है यह पृथ्वी के आधे आकार का है. Now here the sentence tokenization is done for the Hindi language. Now let's see the step 2. A bag of words will be generated of one of the files in the form of a dictionary using gensim's corpora.dictionary object and dictionary.doc to bag of words object. Gensim requires the words or tokens to be converted to unique IDs. So gensim lets you to create a dictionary object that maps each word to a unique ID. Let's convert our sentences, that is list of words, and pass it to the corpora.dictionary object. The dictionary maps every word to a number. Gensim lets you to read the text and update the dictionary one line at a time without loading the entire text file into the system memory. Now here the bag of words will be created. The next important object you need to familiarize with in order to work with Gensim is the corpus or bag of words. It is basically an object that contains the word ID and its frequency in each document. Just list the number of times each word occurs in a sentence. Note that a token typically means a word. The document can typically refer to a sentence or a paragraph, and a corpus is typically a collection of documents as a bag of words. Now we create a bag of word corpus and pass the tokenized list of words to dictionary.doc to bow method. Now in step 3, the term frequency will be calculated for each term in the dictionary using gensim. Term frequency or inverse document frequency tf-idf is a bag of words model, but unlike the regular corpus, tf-idf down weights tokens that appear frequently across the document. tf-idf is calculated by multiplying a local component with a global component and optionally normalizing the result to the unit length. Term frequency is how often the word shows up in the document, and inverse document frequency scales the value by how rare the word is in the corpus. In simple terms, words that occur more frequently across the documents get smaller weights. In step 4, we create a similarity measure object to calculate the similarity and then save it to our local directory. In step 5, the second file will be opened and compared with the corpus created. After the comparison, an average words in the sentences are calculated, and then average of sentences are then again averaged to a similarity index of the document. Now let's have a look to our code. In this, we are basically using packages such as IndicNLP and gensim. IndicNLP. The goal of IndicNLP library is to build Python-based libraries for common text processing and natural language processing in Indian languages. Indian languages share a lot of similarity in terms of script, phonology, language, syntax, etc. And this library is an attempt to provide a general solution to very commonly required tool sets of Indian language text. The library provides functionalities such as text normalization, script information, tokenization, word segmentation, script conversion, and transliteration. The second package we are using is gensim. Gensim is built as natural language processing package that does topic modeling for humans, but it is practically much more than that of. It is a leading and state-of-the-art package for processing text, working with word vector models such as word-to-word, fast text, etc. Here we are basically creating a text similarity method where both our documents are passed The first one, the text one will be our master document. For each of these, we will passing it to the Indic NLP library where word tokenization is done, and then using gensim, we are creating a dictionary or a corpus, and then calculating the tf-idf for it. Similarly, we are carrying it for the second query document. This for basically calculate the similarity between the two documents and returns the percentage of similarity. Now let's start the demo of our application. We have created a GUI for this using tk-idf package. This is the home screen of our application developed with the help of tk-idf package available in Python for GUI. There are buttons to load the files. This button is to load file 1, so let's do that. I have stored some text, Marathi language text in my file, so let's load it. And there is another button to load the second file. Now, as you can see that when file is loaded, the preview can be seen on the respective text boxes, and when both the files are loaded successfully, you can click on the compare button to know the similarity between two documents. After comparing, answer is displayed at bottom, which is in this case is 44%. We have also provided a reset button to clear everything on the screen and start a fresh comparison. Now let's see some of the applications of text similarity. Now, as we know how the application works, let's see the application, the clustering. If you want to group similar text together, how can you tell if two groups of text are even similar? Second is redundancy removal. If two pieces of text are so similar, why do we need both? We can always eliminate the redundant one. Think of duplicate product listings or same person in your database with slight variation in the name or even HTML pages that are near duplicates. Third, information retrieval. How do you rank documents that are similar to a query? You could start with something as simple as cosine similarity. While there are more established document retrieval measures like BM25 language models and PL2, you could also use a measure like cosine once you have vector representation of your query and document. You can even use Jacquard for information retrieval tasks, but this is not very effective as term frequencies are completely ignored by Jacquard. Thank you so much.